There we go. All right. Now we're officially ready. We're only 10 minutes late. All right, so goals for today. Talk about syllabus, talk about how you're going to get the best results you can, or at least the results you need in this class. I'm aware not everybody goes into a class wanting to get an A. I assume that, at least. I think that's probably not necessarily true of some students. Some students might be totally fine with a B or a C. That's great too. I'm going to assume everybody wants an A though. And so I'm going to go through some strategies, sort of, I won't call it game theory because that's a very specific mathematical term, but basically how do you optimize your points and increase your probability of getting that grade that you're looking for in this class. And some of these techniques and strategies will be useful in other classes too, hopefully. And then we'll talk a little bit about why I teach chemistry, what we're going to learn in this class, and go from there. So I know I mentioned already that when we go through the syllabus, I want it to be an open dialogue, talk about all these. Here's just an example of some questions that I'm going to try and answer. What does something mean on the syllabus? What do you need to know from the syllabus? Why did you set up the class the way it is? Turns out that faculty have the ability to design a class however we want for the most part. So any design decision you see was there for a reason. So if you have questions about why we do things a certain way, this would be a great time to ask. Anytime. I'm open to that question anytime. And then we'll talk a little bit about the class. Why do you have to take this class? And then a little bit about me at the end. So when we talk about the syllabus, let me pull up that file. So in general, your syllabus usually starts off with something that looks like this. Here's your class, here's meeting times, here's where we meet, all this good stuff. This is all required by the state of California, by our community college here. And it's also just good information. It's not necessarily easy to parse though. I assume that you know that we meet at 10:15 in room A255, as you all here. But it's also required to be on the syllabus. Labs will meet once a week. You'll either, if you're in lab section 1, if you're in section 1 of this class, your lab is on Monday from 1 to 4, 1:30 to 4:30, sorry. And if you're section 2, then you meet same time slot on Wednesdays. And science lab, I'll walk everybody down there at the end of class so everybody knows where it is that way. Downstairs, go that way, look on your left as you head out towards the back of the building, and you'll find the chemistry lab. It's S103. All other stuff that's required in here is the course description. I assume most of you have read this at least at some level because you signed up for the class. You know what class you signed up for. But this is the section that I actually find the most useful. The two things that when I was a student, I went through the most. Don't pay attention to the date. I'm still in the process of redoing that. This is from a different year in spring term. So ignore the date part. But this is what I would be looking for. Covering on what day do we. And so this is where most of that information is going to be. If you have to miss a day and you want to know what material you're going to cover, one, go to Canvas because you'll be able to check out the slides there and get the recording after the fact. But also you can look at it ahead of time to see what's going on, what to expect if you want to know before you come in, if you want to do some reading before you get to class. That's not the kind of student that I was, but some of you might want to have a heads up or have seen some of the stuff before you come into lecture. I was the type of student that would come into lecture mostly blind and then go read the textbook afterwards or study up afterwards to try and, but it doesn't really matter the order. It's kind of a personal preference thing. Some things you need to spend some time with, you need to see them a couple times. So it's your personal preference if you want to do things before or after we actually have the lecture. General gist of what we're going to cover though for this class, we're going to talk about how numbers and units work, We're gonna talk about energy and phases of matter. We're gonna talk about the periodic table a lot. We're gonna talk about how to name stuff. We're gonna talk about why molecules are shaped the way they are. We're gonna talk about how gases behave. We're gonna talk about solutions and electrolytes. And then if we have time at the end, we'll cover nuclear chemistry a little bit. Talk a little bit about what nuclear reactions are, which is always a fun topic because we get to use the most famous equation of the 20th century, the one that Einstein's known for. Anybody want to take a stab? But what equation is Einstein most well known for?
MC squared.
That's the one, E equals MC squared. So if we get a chance to get into nuclear chemistry at the end, then we'll get a chance to actually use E equals MC squared in this class, which is always kind of fun. It's a good carrot at the end of the term. And if you don't get to it in this class, then you might be taking general chemistry. Are any of you in here to satisfy the prereq for Gen Chem? Got at least one, a couple others. I'm gonna have you, anybody who's planning on taking the Gen Chem series, stick around at break and talk to me about that because you might not actually need this class. So I'll tell you more about that. If you're planning on taking general chemistry next year, and this is the prereq for it, talk to me. For a few reasons. Other stuff on the syllabus. The other thing I always looked at for a syllabus, there's always this required this is a zero textbook cost class. We don't really have a physical textbook, which is concerning to some people. I use a lot of online resources and I use my slides as basically as the textbook for this class. If you really want a physical textbook that you can get for relatively cheap, this book by James McMurray, Fundamentals of General Organic and Biological Chemistry, is the same one that's used for Chem 117 next term if you're taking that intro to organic and biochem. There's probably a handful of you in here who are taking that. It'll be the same textbook, but it's just a good overview that's out of print at this point, but you can get used on eBay or Amazon, or we have a bunch of copies at the library you can check out for the term if you want a physical textbook. There's also a couple PDFs floating around the internet in areas that I cannot promote because I cannot promote piracy. It'd be a really terrible thing if you went out and found digital copies of textbooks for free. That would be a huge benefit to you, I'm sure, and those poor publishers. Won't somebody think of the publishers? So there are some PDFs floating around if you talk to the right people on campus. All my old Z library links are all dead now because the federal government. But besides that, there are a few people around campus and the tutors that know how to get PDF copies of the textbooks as well. If you talk to them, they can help you find a totally legitimate PDF version of this textbook that you will have to pay for, definitely. But you don't need that to succeed in this class, right? You can do it just with the slides and lectures and the links that I'm going to provide. And I think that if I had to guess, I think that's how most people take this class. I'm not in your shoes. In our faculty, we like to assume that when we tell you to go read something, you all go read things, but that's not really the case. If you just want to pass the class, slides and the links that I'm going to give you are going to be good enough. As long as you're doing the assignments. Which brings me to the next part. We'll talk about that more in a minute. The other thing that I always looked for as a student was this right here. Where are the points in this class? What do I have to do to get an A in this class with the least amount of work? So the way it's set up right now is that the assignments category, which is going to be labs, going to be some homework assignments. We don't do a ton of homework assignments, so it's mostly the labs, but there will be a couple homework assignments thrown in here and there. And some of our labs they're considered labs, but they're paper labs, meaning that it's basically just doing some calculations. They're all going to go into that category. You get to drop one assignment out of that category. So to account for things like I got sick and I missed my lab and I don't have any credit for it. We're also pretty lenient with that as far as if you do the calculations, the way we grade the labs, I say we, I'm the only one in charge of this class, but the chemistry department as a whole generally gives half credit on labs for being there and going through the procedure, and then half the credit is doing the write-up and calculations. So if you're not there, you can't get credit for being there, but you can still get 5 points for doing the write-up if you borrow somebody else's data. You just write, this is not my data, so you don't get dinged for plagiarism, which is then a 0. But we're pretty gentle with that. And then if you just completely miss it, an entire assignment, you do get to drop 1 assignment in that category. Same with the quizzes category. The quizzes are going to be set up, they're not really a quiz for the most part. They're not a close your books, sit down, take out a pencil, let's have a pop quiz sort of quiz. The quizzes in this class are going to be every weekend. Because basically if you are signed up for this class, it's Mondays and Wednesdays, right? Which means you can go from Wednesday till the next Monday without thinking about chemistry, which I find is not really good for retention. In general, it's really tempting. Again, I'm going to tell you some things about me as a student that I'm not recommending you do. I was a bad student for the most part. I would 100% have not thought about chemistry for the entire weekend if I didn't have to, if I had 5 days off from it, at least when I was 18. I don't want you to do that. So basically, I'm going to force you to think about chemistry. And it's for your own good. I'm doing this for your own good. Basically, about on Thursday at noon, your quiz will go live. You can start taking your quiz Thursday at noon. And then you have from Thursday at noon till Sunday at midnight to take the quiz. So it's no time limit, it's open book. It's basically a homework assignment. I call it a quiz so that I can regulate when it turns on and turns off and use the auto grader on Canvas. But it's basically going to be, here, think about chemistry over the weekend. What did we do? It'll be, no more than an hour of work to do that quiz. But it's basically, I regulate when you can start and finish the quiz so that you have to do it in those 5 days that otherwise you wouldn't think about chemistry. So it's inconvenient if you do a lot of other stuff on the weekends, if you're in the wilderness education program and you're doing avalanche classes all weekend, every weekend or something like that. It could be really inconvenient. If that's the case, talk to me. If you work 12-hour days, 4 days in a row on the weekends, then talk to me about it. We can see if we can change that time slot a little bit, but the whole gist is after you finish lab on Wednesday, go away and do something else for a little bit and then come back to it and think about it again. There's been a lot of research that coming back to something after you walk away from it, but less than 5 days later is really good for retention and understanding everything. So that's why I have that set up the way it is. And you do get to drop one of those as well. There's only 12 weeks in the term, so there's only going to be not even 12 quizzes because you don't have a quiz during finals week. So I think it's a pretty easy way to make sure that you're at least thinking about the material so I can check in with you. Gives you a chance to ask me questions. You get 2 points on the quizzes just for asking me a question about chemistry. So out of 10 points on every quiz, 1 or 2 of them is going to be ask me a question. And it can be about anything from material we cover in this class. Like, hey, you said this in class and I really don't understand that. Or number 2 on this quiz I just took was really confusing to me. Can we go over it in class? Or it can be, if you're feeling pretty good about the material, it can be, hey, I watched The Martian last weekend and he said something about water using, azide, the sodium azide. Can you talk about that a little bit? Yeah, so it's a good way for me to gauge how well you all are understanding material and also for you to ask me questions about whatever you're interested in. And you get points for it. It's free points. What I have started to see with this though is that people are not even able to come up with their own questions without resorting to ChatGPT. You'd be amazed. It's free points, literally free points, and yet some people still feel the need to ask ChatGPT, what's a question about chemistry I can ask? I've seen that more times than I'm comfortable admitting at this point. So don't do that. Make it your own questions. But yeah, in general, the quizzes are gonna be the bulk of how I actually assess how well you're understanding material. The assignments, they're there for you. The labs are gonna be going through that lab procedure, but the other assignments in there are gonna be like, hey, here's a whole bunch of practice problems. Finish them, turn them in. I'm not gonna really grade them except on completion. If you have questions about those problems, come ask me. I'll give you the key to them. Your first assignment is a math review that's on Canvas, and I'm gonna give you the key. But if you don't understand something in that math review or in that key, that's on you to come to me to ask. And it can be in one of those anonymous quiz questions, or you can ask in front of the class if you're feeling brave. But the quizzes are gonna be where I actually spend more time on the grading and giving feedback. Because those I'm more sure that you're doing yourself and not just copying a key. It's really frustrating as a instructor to spend a whole bunch of time grading assignments when you know everybody just copied the key and didn't really put much thought into it. So the quizzes are much more effective use of my time, and when it comes to trying to give you feedback. I'm happy to, if you actually do want to spend time on any of those assignments, going through them, great. I will spend as much time in office hours or in class as needed to help you get through those. But in general, it's more on you to say, hey, I'm having trouble with this problem. Can we talk about it? I do want you to submit most of your assignments through Canvas when you can. For this first week, I'm going to force everybody, it has to be on Canvas. I want you to demonstrate that you know how to use Canvas to submit an assignment, because that's going to save everybody a whole bunch of headache if you wind up having to, I don't know, leave the country for some reason and you still need to finish turning in your take-home final at the end. If you have never submitted an assignment on this and then find yourself in that situation, that's really, really stressful. And I'm trying to teach you how to use the Canvas submit button properly via email while you're in another country. Let's get all that out of the way this first week. Demonstrate that you use Canvas, and then I'll accept assignments on paper if you really want. I still recommend doing it on Canvas because then you get to keep a copy and it's time stamped and I can't lose it. So it's a good idea to always put everything on Canvas, and I'm going to require it for this first week. Your first two assignments, that math review and your first quiz, are both on Canvas, and there's no paper involved with them because I want you to practice using Canvas. Hopefully that's really, really easy because everybody here probably grew up using Canvas. But there's always people that struggle with something or got a new phone and can't make it work now. This is your opportunity to get tech help, get all that taken care of. Cool? Any questions so far? You know, throw a whole bunch of stuff at you. This part, I don't like to use this part. I'm sometimes late. I was kind of late today, later than I wanted to be walking in here. I get that life happens. However, I have to have this in here because I had a student a few years ago who would regularly show up to lab 45 minutes late and then just start writing down everybody else's data, and then he would leave 10 minutes later. That's not okay. So I had to include this. If you're more than 5 minutes late, then I reserve the right to tell you, no, you can't do this lab. Which is also for safety reasons. It's not just because for plagiarism, because it's unfair to other students, which it is, but also the first 5 minutes of lab is when we're going to go over all this safety information for lab. Chemistry labs are dangerous. We deal with a lot of dangerous chemicals. You need to know the right way to handle them, what we're dealing with on a particular week. And we cover that at the beginning of lab. So usually I give a couple, I'll wait 1 or 2 minutes after the beginning of lab for people to trickle in, but then we're going to start going. And I would really like you to not be more than 5 minutes late to a lab for a lot of different reasons, but mostly for the safety reasons. Plus, you have lab in the afternoons here. It's not like you have an 8 a.m. lab before you have anything else, right? You're already on campus because you already came to lecture, right? So if you're 5 minutes late getting back from lunch, that's one thing, but you shouldn't be more than, I wouldn't expect this to be too much of a problem with our labs in the afternoons. Again, if you have extenuating circumstances, you're gonna be late and you know it ahead of time, or just, hey, I'm coming from North Shore and I'm stuck behind a snowplow. I'm gonna be 15 minutes late. You can always send me an email safely. Don't do it while you're driving, or tell me when you get to campus if you need to. So I will be understanding as long as it's not a habitual thing. But at the same time, let's try to be on time for lab especially. Lecture, that's on you. As long as you're not disruptive to anybody else, you can come and go as you please during lecture. They're all recorded, as I mentioned. Just don't be disruptive and you can make up your own decisions because your decisions are not endangering other people when it comes to lecture. Lab, I have to be a little bit more strict about that. All right, grading scales standard, 90 is an A, 80 to 90 is B, 70 to 80 is a C. There's a little bit of wiggle room in there for rounding to account for things like effort, how often you showed up to class. If you're sitting at an 89.1 at the end of the term and you made it to every single class and turned in every single assignment, I'm a lot more inclined to round up than somebody sitting at an 89.1 who I saw your face once. It's not really possible with the labs, but you get what I'm saying, right? So there's a little bit of room for rounding. I take that all into account. It's not something you have to ask for. So I don't need 48 emails during finals week saying, hey, and in general, this is something that I've talked about with the other faculty on campus. If you're more than like 1 percentage point away from that cutoff, it's probably not worth sending an email unless you've got some really big extenuating circumstances. I've had students who had an 8.8 asked to be round up to an A. That's just kind of insulting a little bit, especially to everybody ahead of them who actually did show up and put in the work. Unless you have extenuating circumstances, you don't usually need to ask for that round up. Does that make sense? Seem reasonable? And the main thing, everybody gets focused on themselves. It's easy to do. But what I'll remind you of if you do ask, and I don't think it's appropriate, well, you didn't put in the same level of work and effort as these students that are a percentage point above you. They're still going to get a B. I'm not going to round you up to an A past them. So just consider what's fair to the entire class. And generally, when I remind everybody of that, everybody's like, yeah, no, that's fair. I didn't actually show up to class as much as I should have. I'll take the B. So we're not going to be in that situation though, because everybody in this class is going to get an A, right? Everybody's going to have a 90 or above. And I get to give my first big class of entirely A's. That's what we're aiming for. That's possible. Everybody starts out with an A, right? You just have to keep turning stuff in, keep showing up, and everybody gets an A. At least a B. Is there anything else on here? Due dates and late work. I leave all the assignments open the entire time. You can submit late work. Typically what happens, all my assignments are out of 10, because why would you ever make an assignment that's not out of 10 points? It just makes it easier for the percentages, right? Other than the final, which is out of 100 for the same reason. Typically what I do is I'll take off 1 point for every lecture it's late. So after 2 weeks late, that's about half credit. But I also don't consider if the deadline is midnight on Sunday and you turned it in at 12:05 on Monday morning, technically, it'll get flagged as late on Canvas. When I go back through and grade, I'm not going to take any points off for that. If it's turned in before I would reasonably wake up and sit down at my computer in the morning to start looking at your grades and your assignments, anytime in that is totally fair to turn that in, and you're not going to be marked late. So I try to be lenient with those due dates as well. I'm not going to be a stick on that. Other than the very end of the term, when we start getting up against finals and I have to get grades turned in and things like that, there's going to be a hard line there. Other than that, I'm pretty generous with deadlines and due dates. It says assignments more than 5 days late may not be accepted. That's basically the nuclear option. If everybody starts turning things in several weeks late, that's not gonna make me very happy, because I'm expecting you all to put in work into this, the same level that I'm putting work into writing the assignments and lectures and grading them. So basically, I will stop accepting late work if it becomes a problem. I leave this in the syllabus, so you know that an option. I've never had to do that. You all generally respect my time enough, and I respect your time enough that it's not usually a problem. But I leave that in there because I don't want it to ever be a problem. And does that make sense? So late work, try not to be late, but if you are late, it's not that big a deal. Life happens. All those dates are wrong so far. Next Friday is the last day to drop the class. That's the one I want to highlight. Not that I anticipate having a ton of people drop the class. But just in general, if you are feeling like the math is too much, you're not ready for this, you need to go back and take a math class first. This class is asking too much time because of your work schedule, or you're taking too many classes, whatever reason. If you need to drop this class, best time to do it is before next Friday. I would encourage you to talk to me about it first, so we can make sure that that it's the right decision for you. But that next Friday is the big day for that. And then withdrawals, there's a little bit more leniency. You can apply for a late withdrawal later on. The withdrawal basically just doesn't affect your GPA, but it also doesn't count as passing the class, but it still shows up on your transcript. So other colleges will see that. It's not ideal, but it's better than getting an F. So if you have extenuating circumstances, especially like, it's just after midterm and I got into a car accident and I'm in the hospital bed for the next 3 weeks, that would be a good time for a withdrawal. Or my mom got sick and I'm gonna have to go home and take care of her, whatever it is. You don't have to tell me what the issue is, but withdrawals can be useful for that. If you've never had to deal with a withdrawal before, that's the sort of thing. If you're just way underwater, if you're way behind, there's no possible way that I'm going to catch up. I would still encourage you to talk to me or whoever your instructor is, because there might be things that you're not seeing, or it might just feel overwhelming. I'm the type of person that once I get behind on one thing, I let it snowball. I get so overwhelmed by being behind by one thing that then I let it become 2 things. Then pretty soon it's 12 things. If you're that personality as well, talk to me about it, because there might be a couple of easy things we can do to get you back on track. So that's why I say talk to me before you just do a withdrawal, especially if you've already gotten halfway through the term. But ultimately it's your decision. So do what you need to do what's right for you, and hopefully we can figure that out together. All right, anything else on here? So that's the format of the syllabus. I always look at it more in terms of, this is the stuff that matters. Grades, we already talked about. Due dates and late work, we talked about. Attendance, group work, we didn't talk about cheating yet. Materials, I talked about the textbook. Lab manual, I'm going to give you. Manual, basically we'll just have printouts for you at the beginning of every lab. So we'll just copy them for you. You don't need to worry about buying anything. Goggles and a calculator. Goggles, we have community goggles in the labs that you can borrow. You can them with everybody else that is in a chemistry class this term. We do wash them every week or so. But if that skeezes you out, pair of goggles. Your class, you take a whole bunch of science classes in your for yourself, have your name on, and then the space is going to be touching them. It's not a bad thing to do. The main thing I would say is that they have to make contact with your face all the way around your eyes. You can't just go get safety glasses from the hardware store that look like sunglasses, because those are proof. They're also not rated for chemicals. They're rated for impact. And so what happens if you actually get chemicals on those is they dissolve, and now you have both chemicals and melted plastic on your face. So they have to be rated for a chemistry lab. They have to make contact with your face all the way around. Especially if you wear glasses, it can be a good idea to get your own because you can make sure you get some that fit over your glasses. They have some models on Amazon for $20 that are designed to fit over glass frames. Because we don't want you to not wear your glasses, but also you have to wear safety glasses on top of them. So if you need help finding things, or you want to check with me to see if it fits the criteria before you hit order, I'm here for that. But you can always just use the ones that are in the lab. They're not in terrible shape. Yeah.
When do I need them by?
I don't think we need them for next week's lab, so it would be the week after that, week 3. Right, so you've got a little bit of time. You can come check out and see what the community classes look like. That might help you make your decision. I don't think they're that bad. I'm not the sort of person that gets weirded out by that, but I recognize that some people are. The other thing, calculator. I'm not particular about what sort of calculator you use. You need to have a calculator that can do logs and that can do exponents. But other than that, any scientific calculator will work. We have a couple of loaners in the lab that you can use. We don't check them out for the whole term. If you forget a calculator, you can use the ones that are in lab. I'm also fine if you get a scientific app on your phone. But I want you to be using, get practice using the calculator that you're going to use on the final. Because the worst case scenario is you use your phone for calculator the entire time. And then you go down to SAS to take your test, and they won't let you use your phone as a calculator. And then you're stuck using a calculator that you've never seen before, trying to figure out how to make it do the calculations you need it to do. You don't want that. So we want it to be, if you're going to be taking your tests with me, I'm okay with you using your phone as a calculator on the test. Just make sure it's on airplane mode, and it's, to be really honest, it's really obvious to see when people are using their phones to cheat. Using it as a calculator, it sticks out. So don't do that. That said, if you always have your phone on you, most people do. If you want to just use your phone's calculator, most phone calculators, if you turn your phone sideways, has all the scientific buttons. You can download a different app. I have an app called Hyper with an I, that is basically like a TI-83. It's on my phone. $5 because I use it enough that I felt obligated to. But there's a free version of that as well. Or you can use the one that's built into your phone. Me is used to using the same calculator all the time. So because practice using your calculator, because using a calculator is a skill. Else. Any questions about any of that stuff so far? All right. My least favorite thing to talk about is the academic honesty side of things. There's a blurb about this in the syllabus as well. I want you all to work in groups. Working in groups is good, especially for tricky problems where you're trying to work to understand the concepts and things like that. You working in groups and teaching each other, figuring things out together, really, really valuable way to learn things. So I'm not taking that away. I want you to work in groups. When you turn something in, though, the assumption is what you turn in, you understand what you did, what the calculations are. So that's the difference between working in groups and just copying someone else's answers. If you don't understand what you're writing down, if you're not there when it's being worked on contributing to it, don't write it down. Take a point deduction or something like that and get into the better habit of, I didn't understand this, or I didn't leave myself enough time to finish this, so I'm just going to take the 1 or 2 point hit. Because if you get in the habit of copying and then you get to the test and you don't understand anything, the temptation is going to be to cheat on the test too. And that becomes a problem and becomes really obvious. And that's when we start getting into disciplinary referrals, things on your transcript that you don't want on your transcript. There is no worse thing for trying to transfer to another school than having disciplinary action. Even if it doesn't say what the disciplinary action is, schools are gonna assume it was cheating, it was plagiarism. So even if it's a sealed file, you don't want that. It's really not worth it. Take the 0 on that assignment if you need to. Don't turn in the entire assignment because you didn't understand it. Don't turn in somebody else's work, and that includes AI. I played around with various AI systems before with some of my problems from this class. It's really obvious when one of my students is answering a question versus when AI is. AI doesn't even get the right answer 2/3 of the time, half the time. Half the time AI would get a close enough answer that I would give it a 9 out of 10. But it does it in such a way that's really, really obvious to somebody who's taught you all the only right way, but like this is the way that in this class we're thinking about this. This is how we show our work. And then I get a ChatGPT answer. And it's really, really obvious that it was not somebody that's actually taken this class. So don't do that. So same goes for Chegg. I don't have to warn people about Chegg as much. Anybody still use Chegg? You may even heard of Chegg. But basically, before AI took off, you could take a picture of your homework and you'd upload it to a website called Chegg, and then somebody in India would do your homework for you and send you the work. I'm not making it was in there. I tried to get hired as one of their workers to see and part of their hiring process says you have to live in India. So it was very, very specifically targeted. They did all their marketing and everything was in American universities and colleges, but to work for Chegg, you had to live in India. And it was for tax reasons, I think, something like that is what they said. But basically, I swear I'm not being racist. That was just the actual thing. So don't use Chegg either, but Chegg answers were better than ChatGPT answers, but they still were really obvious to see. And I really don't like having to deal with that. I also really, even more so than disliking dealing with cheating, is I dislike when people get grades that they didn't earn or better than people that did put in the effort and got a C. So I go out of my way to keep my classes fair to the people that are actually showing up and doing their own work. It's not because I'm trying to crack down on cheating or anything like that. I just don't think it's fair to the people that actually do the work. And so with that in mind, the worst example I ever had was somebody who submitted a question on the in-class test to Chegg during the test, somehow managed to get their phone, take a picture of the problem, submit it to Chegg, got an answer back before the end of the test. And then I found it online a couple weeks later and had to retroactively go back and fail the student. I don't want to do that. He thought he got away with it. He did get away with it for about a week, and then it became obvious. But anyway, that's not an issue because nobody in here is going to do anything like that. We're all going to get our A's because we're going to show up and put in the work and think about chemistry, not because we're trying to cheat our way through things, right? Right. All right, any other questions about any of this stuff, syllabus stuff? Okay, a couple last minute. There they are. We'll take a break here in just a second, but when it comes to the way the class is structured, percentages wise, in the different categories, I want you to try and plan order around what you're good at. I think you don't think. We're going to talk about that in a second. If you know, again, that's something we're going to look at. I have strategies that can help you get better at taking tests. If you know that you're going to struggle with the tests, then make sure that your other categories are better, or you've done pretty well on that. If you have a 95% in your assignments and a 30% and 85% in quizzes, you can get 55% on the final. You fail the final and still get a B in the class if you plan to head for that. Right? The reason that these percentages are pretty even across the board is so that no one category is the same. On the other hand, If you know you're gonna miss a lot of labs because you know your personality or you know your work schedule. If you know that the assignment's 75% about, it's gonna be about as good as you can get. You better make up your work in other areas, but you can still get an A. Or sorry, you can still get a B pretty easily as long as you are doing what you can and then making up for it in other spots. So know yourselves, get to know how you are as a student, plan for this a little bit. If you fit into this first category, I would really encourage you to not miss class. I know I record things and make it easy for you to make up the stuff later, but being in class is just a different experience. Your brain processes the stimulus different than watching a 2-hour YouTube video. Right, so it makes a big difference for you to be here, especially if you know you're a person that's gonna struggle on tests. If you've got a tough work schedule, tough class schedule, and you know you're gonna miss some labs, then we're gonna have to work to make sure that you're gonna do okay on the final, to still get that B. This was the sort of thing I will work on doing this calculation so you can do it yourself. This is the sort of thing I did in every single class in high school and in college. I would sit down at the beginning of the term and figure out, okay, where can I slack off? Where do I need to work? Time it out, figure out what the schedule looks like. It was the sort of thing that just made sense to me, to try and optimize points, get the best grade I can for the least amount of work, because I'm an engineer at heart, and by training. So it's the sort of thing where you're trying to optimize and get the best outcome for the least effort. That's not a bad way to think about college courses, honestly. All right, let's take our break. Take a break in every lecture. It'll be 10 minutes. Little bit short on this one just because that scaling issue at the beginning of class. Come back a quarter after 11:15 and we'll pick up. And if you're taking Gen Chem next year, come talk to me real quick. You too, right? So this is listed as a prereq for Gen Chem, but it's actually not really necessary for everything we cover in this class. In Gen Chem, just in more depth, more matter. So basically, it's had basically where you're strong on math, good at you can do the math. It's pretty straightforward, easy for you. They probably don't need this class before the Gen Chem service.
Like the rest of the intelligent.
Might want to take this class if you're the sort of person who wants to go.
Okay.
But I would caution you against that. Some just because this class is a lot of like competitive. You get your Gen Chem. And it would also be this shouldn't necessarily, I'm not trying to pressure you to drop this class. If you feel like you want to take this class, but we do have the wait list on this class as well. So I always give this field to anybody who's taking Gen Chem next year, because if you don't need this class, you might want to give a spot to somebody who does need this chemistry class. But if you're feeling like it's a little bit intimidating and you want to take this class, stay enrolled. That's totally fine. Just something you don't make a decision now. Make a sign it right now. About it, talk if you want to after class. But something to consider.
You say math for you?
That's not.
Right. I saw in the pre-run release for this one, the theme math was kind of like combined. Which I think was all
Well, yeah, it's been algebra 2 basically. You took algebra in high school. Yeah, I felt pretty good about it, like doing functions and graphing. Okay.
Yeah, sure. So in my case, math was actually my weakest subject, science was my highest, so on, but it still put me at college ready. So I'm assuming
So I would say, so do the assignment, the math review, and if you feel good about it, you probably get, it's the math review that we do for Gen Chem is gonna be almost the same assignment, like 2 extra problems at the end.
Okay.
So it's really, these two classes, this is like condensed and less math heavy, but it covers a lot of the same topics that we'll cover in Gen.
That makes sense.
It's just in Gen Chem, when we get to the second or third quarter, we start bringing in a couple of new concepts that we want to do. First quarter, it's almost identical.
Start with the lab.
Yeah, so there'll be more of them, because it's a whole year-long series, and it's gonna be, the labs are a little bit more in-depth, it's basically, we expect more on the algebra and on the calculation side. So we'll do some word problems, conversions, things like that, it's less of an emphasis for the syllabus. So that, I think I forgot to help on campus before I walked up here, so it's not. I'm trying to figure that out right now. Are you Bianca?
No.
Okay, Bianca sent me an email too.
Yeah, this one right there.
Okay, thank you.
I mean, I feel like.
Yeah,
I don't want to. It's like, yeah.
not much. Yes, I would, try not to reuse those because like dates change. Things like that. But yeah, if you just want material,
Yeah, I kind of did that for this one.
yeah, it's the same stuff over and over again. But just specifics, the questions that are asked, the emphasis just will change a little bit depending on what I have in class and what their interests are.
Okay.
But substantially.
Thank you.
She like. Girl, you just started. She's like, don't get on. Thank you.
So the waitlist online, I've noticed that it's closed.
Our waitlist system has problems right now where it like resets the first week of classes. So I'm gonna get the list of who was on the list at the end, so I can get who was in what order. And we'll, this students I'm gonna talk to after, basically I'm gonna give you a canvas and we're just gonna pretend you're in the class for the first 2 weeks until that drop deadline hits. And hopefully there's some will drop and they decide they don't need this class by then. And hopefully we can accommodate everybody, but I can't guarantee anything. There's not lab day. So any day that we have a Monday off, we also won't have lab on Wednesday to keep it the same schedule and get the lab session. Okay. Not, so half of you will have lab on Monday and half of you have lab on Wednesday. So it's not. Just one. You can pay for a copy of the map. Lab day, but then we. That math review I was talking about, calling that the first lab assignment. And if you want to copy. First, it's online.
It's not really.
Oh. Right. Right.
Psychology.
Yeah. Covered last week. Sorry, the next class you can catch on the recording.
I like.
All right. So I was able to get the Canvas show published. And got locked in here so that I can give you a brief tour. It's a Canvas shell, it's not super tricky. I just have everything set up so that assignment announcements show up at the top and then underneath the announcements. I just have it set up by week. So for week 1, you click on it. You've got some goals for week 1. These are kind of go away once you get the hang of things, but the main thing is down at the bottom. This is where I'll post a link to the slides as a PDF file. And then the lecture video, once it's done rendering, I upload it to YouTube. I'll link that here as well. That takes a couple hours. It's not available right after class ends. But this is where you can get all that information, and then the textbook sections, basically some web pages that are designed to help you, mostly using LibreTexts for this, or from a structure that follows the same order of the material as that McMurray textbook. But basically, this is going to be the textbook that we're going to use. It's really just a series of web pages that's available for free that mirrors that McMurray textbook. And then the other thing where you can get to any assignments is I use the sidebar over here a lot on the left. If you just want to see what assignments you have and what get to any of these, you go to any of the assignments. When you click on the assignment, and then it loads. I'm always just going to link a PDF of the actual file, so you don't have to show up and pick up the file itself. You can always get a copy of whatever the assignment is from Canvas as well. I'll usually have a paper copy of everything for you too, but you have this option, and then you can submit your assignments here as well. And so here's the basics of what we're doing for the math review. Here's some practice with scientific notation. Do some basic algebra, solve for X. Scientific notation, math. And then more solve for X in terms of Y, which means get X by itself, but your answer is going to still have some Y's in it. And then do some algebra aren't X and Y. For those of you who have had, high school algebra and haven't taken a lot of science classes yet, for whatever reason, this concept is hard and intimidating. It's still just algebra. You're still just moving variables around. They're just not X and Y. So we're gonna do some practice with that. So because we don't do things with in sciences, we use variables to tell you what type of unit that is. We won't get to this one until towards the end of the class, but this equation is pressure times the volume is equal to number of molecules times a constant times the temperature. It's still just an algebra expression though. If you know what those variables are and what the units are, and you just plug stuff in and do algebra with it. So this first one, or this last problem, is practice moving variables around that aren't X and Y, because we're going to do a lot of that. All right, so I think that's all you really need. Basically, I also use this as a way to let you know where we are in the term, because every week I'll go through and I'll change the code to make this one blue and this one will turn red next week, so that you know what week we're on. And then you can go back and find the old material if you want. There's some random resources and study tools. If you want to just look at sciencey sort of stuff, there's some random stuff in here that you might find helpful. Some of these I'll reference This one would really stress out this computer, so I'm not gonna click that one. But then just a good periodic table that's online. This is kind of fun. It's just a little Java applet that when it loads. You can basically zoom in and out. There it goes. So you can- It's a basketball. The largest hailstone ever recorded was almost the size of a basketball. That's kind of cool. Yeah, this is really smart. There it goes. Japanese spider crabs. You know, Japanese spider crabs get to be 10 feet across. And they look like spiders. So if you really don't want to sleep tonight, you can read up on Japanese spider crabs. And I don't know, maybe not everybody feels the same way I do about spiders, but I don't really want to go scuba diving with those. But then you can go really, really small. It's just fun stuff. A white blood cell, E. coli, clay particles, X chromosome. So anyway, there's just put a bunch of random sciences stuff on here. YouTube channel, stuff like that. If you're just looking for stuff to get some insight into my brain, you can see what I think is cool. The online tech is there. Link the syllabus once I fix those dates that I mentioned. I'll put the syllabus is going to be linked there along with the schedule. My weekly schedule. I have office hours. Has everybody heard office hours before? Does anybody know what office hours are for? General questions. You're supposed to come ask questions in office hours. I had students that said, "Oh, I thought those were the times when I'm not supposed to come bother you because you're doing paperwork or something." No, office hours, we're trying to kind of rebrand them as student hours. So basically, they're hours that we're guaranteed to be in our offices specifically to answer questions. So anything you don't want to bring up in front of the whole class, you're doing a homework assignment and a new question crops up. Office hours when you can come find your instructor. My office hours are 9 o'clock to 10 or 10:30, depending on the day. On Monday through Thursday, I'm around a lot more than that. You can always come find me though, and if you know where I am on campus, come check my office first. But any questions you have, you can come to office hours and ask me those questions. And if you're not able to be here in person, then I have Zoom as well, clearly, so you can always Zoom to ask questions or email me. It gets hard to explain tricky chemistry concepts via email, just because the nature of typing, and it's not an easy thing to explain abstract concepts via email. You can always call it like that. If you do want to just email me, I will also say that the fastest way to get a response to any email, this is just good life advice. If you want a fast response to your email, make it really easy for them to answer it. Make it a yes or no question. So in terms of asking for help on chemistry, how do you do that? You take a picture of your work, say, I think I messed up somewhere, but I can't see it. It's going to be harder for me to answer than, am I on the right track? I can say yes, or I can say, no, you're missing this issue over here. Right? The faster it is for me to answer an email, the faster I answer the email. Not to say that, so basically, I don't understand units is not a good email to me, to an instructor, because that's a whole can of worms you're asking to open via email. That's a better in-person question. And the more specific you can make your questions, the more I can help you. So you can say, I don't understand why units do this, is a better question, or is a better thing to start with than, I don't understand, I'm lost. I get that you might feel lost sometimes. It's okay. It's appropriate to ask that sometimes, but it's a lot easier to get help if you can narrow in on what specifically you don't understand. That's just good advice for college in general. But that said, if you really are just straight up lost, I'd rather hear that than not hear anything from you. Make sense? All right, back to anything on here. Basically, in terms of tips for being successful in this class, do the homework, do the quizzes. I don't want to grade assignments. Literally ever. So if I'm asking you to do an assignment that I know I'm gonna have to then grade, it's because it's for your own good and I'm trying to get you to understand something about it, right? If I could just design the class to where I only had to grade one test and nothing else for the entire class, that would make my life a whole lot easier. The class isn't set up that way because I want you to actually do these assignments and understand what's going on. Right, and in general, if you do the assignments, it correlates very strongly with how well you will do on the test. The reason that some classes are designed to just be a test as your entire grade is because final exam scores are almost directly correlated with how much time and effort you spend on the other assignments. So why bother grading the other assignments is the thinking that other professors at other bigger schools. I did my grad school at University of Colorado, which is a very big school, in the engineering department, and my first job there was as a TA for their general chemistry for engineers class, and it was, I want to say it was 530 students. And so every single assignment had to be graded 530 times. Any assignment that was given. We didn't give many assignments in that class. Because it was just not possible to do that for the most part. Basically, there were 20 TAs and we took turns. Everybody had to grade one assignment and then we all got together and graded the tests together at the end. But basically, once per semester, I would get a stack of 530 assignments and have to grade all of them in less than a week. And it was awful. I don't want to do that. That's why I teach in community college, because there's only 48 of you. A little bit more than 48 with the wait list. But if I'm asking you to do an assignment, it's because it's going to help you. If you can do it, at least help you figure out what you don't know, which is a big step. If you don't do the assignments, it's hard to know. The other thing we're going to do, this is one of my favorite parts of this class, is happy students learn better. They've done a ton of research. People that are happy and excited learn material better. Even if you're happy for reasons that have nothing to do with chemistry. Well, technically, if you're happy, it's entirely due to the chemistry, but that's beside the point. What we're going to try and do for this class is, obviously, I can't control anything. You can't control everything, and everybody has things going on in their lives outside of this classroom. But what we will try to do is I'm going to ask you to try and leave outside things that aren't chemistry as much as you can. When you show up here, you get to ignore everything that's not chemistry for the next 2 hours. Right? And that's hard to do, but the more you can put yourself in that mindset of, hey, I don't need to think about this other issue. Relationship issues, arguments with friends, whatever it is, whatever you're not happy about outside of chemistry. You don't have to think about that as long as you're here. And to sort of switch gears into thinking about science and chemistry, we're going to start every lecture with some of those random chemistry questions that you all ask me. So on the quizzes that you get to take, those free points at the end, ask me a question about chemistry. Any questions that are relevant to the material we're covering, I'll start class by covering those questions, answering those questions in front of the. I won't put your names to them or anything. Don't worry. But I'd say, hey, 3 of you ask me questions about this. Let's talk about this. Clearly, I missed something because several of you had the same question. Let's answer that. But then also the other fun stuff I get to do is when I get random questions about chemistry, like, hey, how does snow melt work? What's going on with that weird weather we had last week? If you get random chemistry questions, if there's stuff that's relevant to what we're covering or just I think it's cool, I'll start with answering a couple of those, talking about random chemistry applications in every lecture. So it keeps things a little bit more entertaining for me. I get to learn a little bit more about you all as people and what you're interested in. And hopefully it'll help you realize where chemistry does connect to other things. Yeah. Hey, you mentioned this in class. Can you say more about that? I read something about dark matter on the internet. What is dark matter? Like random stuff. I'll take a couple of those every lecture and talk about them beginning in class. This is a way to sort of switch gears leave the outside world outside, switch gears and talk about chemistry. And then we'll get to the action in the material and working through problems and stuff like that. All of that because happy students learn better and happy instructors, I guess I should say, engaged instructors are happier and more interesting for you. So keeps me happy, keeps you happy, should be fun. Usually some people don't, but most people I think like chemistry applications. I'll try to keep it too much of our time. Last thing before we get into teaching philosophy and things like that. Has anybody heard the term fixed mindset versus growth mindset? It's a concept that's been around for a while now. I still run into it a lot. So fixed mindset is the idea that we all have a set of fixed skills, and what we're good at, and what we're bad at, we're bad at. That turns out that's not actually how learning and knowledge works. Just because you're bad at something now does not mean you can't be good at it. And just because it seemed like one particular topic came easier to you, that doesn't mean that you're randomly gifted at it. It just means that you have the right confluence of variables. So where you're like, oh, well, I don't think I'm very good at math, but this one aspect of math I really understood and that happens to dovetail into biology, so I'm good at biology. You're good at biology because of a whole bunch of other factors that go into it, right? And part of that is the growth mindset. Just because you're not good at something now doesn't mean you'll never be good at it. And I would hope that by the time you finish this class, you're considerably better at a lot of things than you are right now. I don't expect you to be able to take the final exam for this class and succeed at it right now, because you're going to get better at some of these skills as we go. Even if you did know all the material, there's still way more to this class than just reading a book and memorizing vocabulary. Getting better at those skills is the growth mindset. So the place where I hear it a lot up here in the mountains is I hear a lot of people say, I'm just bad at technology. I'm bad at computers. I don't like math. Anytime I hear you say things like that, especially if you're trying to say, oh, I'm really bad at computers, can you help me with this? I'm going to correct you. And it's really annoying. You'll be annoyed with me. But if you don't put a yet on the end of that, I'm going to put the yet on there for you. So you're not good at computers yet. You struggled with technology for now. All of those are things you can get better at. All of those are things that you can be better at, especially tests. For better or worse, if you're in this room, you're going to have to be good at taking tests to get where you want to in life. Because if you're in this classroom, it's because you picked a major that is going to require you to take tests. Most of you are probably health majors, nursing, dental hygiene, x-ray tech, things like that. You still have to be able to take tests. It's not fair. It's not the best way to assess learning. It's the easiest way to assess learning across the entire group of people that are trying to get a nursing degree though. So for now, you still have to get okay at taking tests, but we can work on that. Just because you struggle with tests now doesn't mean you always will. Right, so I just want you to always come into this class with that mindset. Like, I don't understand X yet. Right? It seems really simple, stupid, cliche, but it works. So I'll instructor brag. I had a student who couldn't finish the first Gen Chem test. It was a 2-hour test for the midterm for the Gen Chem series. She wanted to be a pre-med student. She was a pre-med student. And she just completely fell apart 15 minutes into the test, turned in an entirely blank test because she had such bad test anxiety. And we worked together. She took 2 years of classes with me. So by the end of that, she transferred to a 4-year pre-med program, graduated with a bio degree, went to med school, and is now in charge of the burn ward in a hospital in Georgia. And she started here completely falling apart anytime somebody put a blank piece of paper in front of her. I don't anticipate any of you are feeling that strongly, but I bet most of you have some level of test anxiety. Most people do, and that's normal. You get to where that test anxiety is more about how good am I gonna be. I thought I had test anxiety, but I always did well on tests until I realized that it was the same feeling as right before an athletic game started, before a rugby game started. I realized I sat down to take a test and I got this huge adrenaline rush. And I'm not anxious, I'm excited. Trying to flip that switch is going to something we work on in this class. Right? It's not, you may never like taking tests. I've grown to like taking tests once I made that connection. But we'll get you where you're feeling better about it at least. All right. We haven't even touched science yet, have we? It's random apps. This is a little bit outdated. If you need an app for scanning your assignments, for turning things in, this is what I use. I think most Apple phones have a scanner function built into the camera these days. I don't think all Androids do. My phone is really old, and so I still use a separate app called Cam Scanner that basically just turns my phone into a scanner for saving PDFs. Some other links in here. Anybody played with Wolfram Alpha before? Wolfram Alpha is really fun. It's basically the best online calculator that you can find. It'll do units to some extent better than most. Oh, opened it. But basically, if you want to, if you have access to a computer but not a phone, or don't want to pull your phone out and start up the calculator app, this is a really good way to ask or to do calculations. It'll even do calculus for you. So you can find the integral, you can find like intercepts, you can solve systems equations. It's super useful, but frankly, just a regular search engine or your phone's calculator is all you really need for this class. All right. Last thing about this class structure. Does anybody know who Robert Heinlein is? Besides the author of Starship Troopers, he's one of the godfathers of science fiction from the 40s and 50s. He wrote Starship Troopers, which is depending on your point of view, it's either a really bad or a really good movie from the 90s. I think it's really good. But the book is pretty good too. It's a little bit war hockey, but it's got some interesting ideas. But it has this quote in it about the best things in life are free. It's definitely not true. The best things in life are not free. What Heinlein says here, though, is the best things in life are things that are purchased with something other than money. Things that you can't buy. That they're not free. Oftentimes, you have to pay a lot in terms of effort, sweat, tears. But those are the things that you'll feel the best about once you finish them. This class hopefully will not have too many tears, but there will be a lot of sweat, not literally brain sweat. It will be a lot of work, but it'll feel really good and you'll feel very accomplished by the end of it. If you stick with it, do the work, you will succeed in this class, right? Everybody can pass chemistry. This is not a weed out class. This is a class for you to learn some basics and some good study habits, and you will succeed in this class if you can do that. All right. All right. So why bother? Why bother teach chemistry? Why bother take chemistry? What is the point of this class? This is usually that when I open the quiz questions up to just ask one question about anything. About a third of the questions are usually why the heck do you teach chemistry? So we'll talk a little bit about why I teach chemistry, why I think chemistry is cool. I think that the universe is a really wild place. I think it's really, really cool, and I like trying to find new knowledge, new understanding, new ways to think about these things. Does anybody know that this figure? Anybody's seen this picture before? You know what it's called?
I don't remember the name of it, but
Oh,
I
I put it
remember the
right there.
story behind it. Oh, yeah, for sure.
The Hubble Ultra Deep Field. Basically, it's that little speck of the night sky. Basically, when the Hubble telescope was first launched, when you have to run something like that that's shared between the entire Earth, every university on Earth can access the Hubble telescope, but you have to put in grant proposals, you have to get approval. You basically have to say that what you're doing is scientific and relevant in order to justify getting a spot, because there's a limited amount of time on the Hubble telescope. And the person who decides that is the administrator of that project. And usually the administrator of that project has a background in this case, astronomy or whatever it is. But that also means that if they're spending all their time deciding who gets the time there, means that they don't actually get time to do their own research anymore. It's sort of failing by succeeding too much. You don't get to do the things you love because you were so good at them that you got promoted. And so this administrator, this woman, I can't remember her name, basically was given time on the Hubble telescope, but she had no time to actually do any research because she was so busy helping everybody else do their research. But she had this thought that, well, what would happen if we took this incredibly powerful telescope, the most powerful telescope man has ever made, and we just took a super long exposure of empty space? And so basically her 30 seconds a day that she got to use the Hubble telescope, she pointed the Hubble telescope at the same empty spot for a year and overlaid all of those images, all of that exposure on top of itself, and discovered this. Basically what looked like empty space had a ton of stuff in. And what's really cool is every single one of those dots in this picture, other than that one and that one, there's a few very faint stars. The ones that you see with the cross on them are stars. Every other point of light on here is a galaxy. This is some of the fundamental research that led them to realize just how big the universe is. And it was just because she didn't have time, but she was really curious. And so she just said, well, let's go see what's there. Maybe we'll find something interesting. Maybe not. I think that story is really, really cool. I really, really like science because it rewards curiosity. Just being interested in what's around you. That's why I like to teach chemistry. That's why I like to study science. I spend my spare time reading science books for fun. This is gonna sound really weird. All of my free time over the break was spent reading a book on international law and how it applies to space colonization. Because I think that that's really, really interesting. And somebody went to the trouble to write a 250-page book on international law and diplomacy and politics and how it applies to colonizing Mars and the Moon. I think that that's really cool. So if we can't ignore it, if it's cool, why wouldn't we spend our time studying it, trying to understand how things work? Chemistry can feel really, really removed from your everyday life. My job is to remind you that it's not. Nutrition's a really good example. Everybody has grown up eating, I'll assume, and has some knowledge of what foods taste good, what foods are good for you. Whether or not any of those are based in science or just personal preference is beside the point. Everybody eats, right? Everybody has some idea about what's good to eat. So why not learn more about that? Why not learn more about why certain vitamins are good for you? This picture, this is another fun. Go the other way. Instead of this astronomically huge, let's go to infinitesimally small. This subway map represents the metabolism of the yeast cell. Every line represents a different enzyme, and every dot represents a different molecule that interacts. Every single one of these reactions is tied together. you change concentration of one thing over here, it affects everything. Everything's tied together. It's incredibly complex. And basically, if you can actually point to on this graph that are where B vitamins are needed by the yeast, where broken down. This section right here, this little repetitive section, this section is fatty acid elongation in the mitochondria. So that's when the mitochondria takes extra energy and turns it into fat for energy storage. This section is breaking down those same fatty acids. This circle here is the citric acid cycle that you may have heard about in a bio class. This section here is glycolysis. Like this area, this picture is the result of hundreds of thousands of people working over the last century since biochemistry was really discovered in about the 50s. So since the 50s, hundreds of thousands of people spending millions of hours to try and figure out how all these things connect. This is how we can understand what nutrition actually is. This is how we can understand why some things are essential nutrients and some things aren't. Why trans fats are bad, but omega-3 fats are good. All of that comes down to this picture and understanding this picture. Now, you don't have to understand everything about this picture. If you're really interested in stuff like this, the most important sections of this picture you would study in upper division biochemistry, where you would learn. So that was a 400 level class in the chemistry department usually, where basically you memorize the names and structures of all the chemicals involved in carbohydrate metabolism, for instance, how hemoglobin works in the body, why the 3D structure of proteins matter, how they're determined. And basically, if you went on from that, if you went to school and studied, you basically would zoom in on a particular part here. There are people who spend their entire careers understanding that. They'll spend their entire careers just understanding. They'll understand some of everything on here, but their focus is zoomed so far in. I think that's really cool too. You can be an expert. If you go to grad school into a PhD program, which may not be on anybody's plans right now, but literally when you graduate with a PhD, it's saying that you are the world's foremost expert on one tiny little bit of something like this. There is one particular organic chemistry reaction that when I left grad school, I knew more about that chemical reaction than literally anybody else on the planet. Which is kind of cool. Why wouldn't I want to talk about that? That's pretty awesome. And you can do that any field that you go into, you can become an expert. You just have to be interested. But really, to really understand anything, you're gonna have some. If you want to be an expert in, I don't know, maybe let's pick something really random. Making paper. Maybe you decide you want to become an artisanal paper maker. You want to make the world's best paper so people can put it into a notebook and write on it. Maybe I bet there's an entire community on people that make their own paper at home. If you really want to understand what's happening when you're making your paper, you've got to understand the chemistry. You want to be a dietitian, you've got to understand the chemistry. You want to be an X-ray tech, you've got to understand the chemistry. You want to be a mechanical engineer, believe it or not, also chemistry. Nothing can really be understood unless you're thinking about it at a really zoomed in level. And I think that's awesome. And that's what we're going to do in this class. So I think I've given you a decent idea about myself. I'm Sean Ryland. I like talking about science. I like talking about a lot of things. I like music, a lot of music, mostly in the rock subgenres, country, hip hop, metal, all that good stuff. If you're into music, talk to me about what you're into. Odds are I've listened to something kind of related to that at some point because I'm always looking for new music. And I'm interested in what you are really interested in. I like games. I don't get a chance to play video games much anymore, but tabletop games, card games, other sorts of games. Here's something. Be excited about something. Tell me about what you like. My son is getting really into D&D right now, which is a good gateway drug into other tabletop games. So, you know, it's interested in video games, tabletop games, card games, by which I don't mean Magic. I've never got into Magic. But stuff like euchre. Anybody heard of euchre before? Euchre is a card game from the upper Midwest that is incredibly fun. People. So more traditional card games for the most part, I guess. I like sports. Baseball is my favorite. My son's really into basketball at the moment because it's basketball season. My wife's family's all really into hockey because they're from Minnesota. But any sports that you're into, I probably am into them a little bit too. I personally played all the really weird esoteric sports because I was small and not really competitive in high school. So I would just find a sport that nobody else was playing so that I could get on the team. So water polo, rugby, wrestling, swimming, stuff where they don't cut you. Mostly was my forte. Things like that. I like food. Most of us like food. I like beer a lot. I got really into the chemistry of beer making, taught a class on it, Sierra Nevada College. That was really fun. They paid me to get really good at home brewing and then teach people about it. That was when I was really living the dream. I don't brew beer much anymore because I don't have time for it, but I still know a lot about beer and other drinks, kombucha. Actually, if you want to talk kombucha, you should talk to Carl Franz, the other full-time chemistry instructor. Tall, skinny guy who wears the suspenders and bow ties sometimes around campus. If you've seen him around, he brews his own kombucha. He's a microbiologist by trade, so he's really good at the kombucha side. I like books. I like movies. I like TV. I like a lot of stuff. I like to be excited about things. I would encourage everybody to just be excited about things. It's really easy to doom scroll your way through life these days and not really be excited about things. I would encourage you to, in your doom scrolling, I'm not saying cut out the doom scrolling because I doom scroll as well, but center it on things that you're excited about, things that you can learn about. The internet's a huge tool if you use it properly. Any other questions about me? Oh, I'm an engineer. So some of you are probably engineering majors. I'm a chemical engineer by trade. But my undergrad was in chemistry, with focus on biochemistry. My research was in organic chemistry. I'm kind of all over the board, a little bit about everything when it comes to, especially chemistry, but science in general. I've mentioned that I taught at a big school when I was in grad school. I've now taught here at a very small school. I went to a small liberal arts school. I kind of have a little bit of experience in a lot of different areas. So if you have any questions about anything about how transfers work in the sciences, counselors are your best bet. But if you have specific questions about the science departments in different places, come ask me. I'm happy to talk to you about whatever you're planning on doing once you go out from here. All right. So that's why we talk about science. That's why I talk about science anyway. So what is science? How do we know what science is? Anybody have any guesses? What defines something as being science or not? Cause and effect? Yeah, but every cause and effect happens whether or not we're talking about it, right? Science doesn't really happen on its own.
Is it creating an answer and then solving it through scientific method?
Scientific method, yeah. And so it's not the answer, it's the hypothesis. And this is going to be one of the things that I will tell you now. One of your questions on the final is going to be about the difference between a scientific theory. What's the definition of a scientific theory versus everyday life use of the word? someone says, I have a theory. What does that usually mean? Versus I know something. Generally, people use that to mean that they're not sure about that, but they kind of have an idea of maybe what's been going on, right? Science is what we call a hypothesis, not a theory. A scientific theory is not the same as the way we use the word theory in everyday life. Hypothesis is basically when you say, I think I understand what's going on here. And what makes something is then going on and testing that hypothesis. It's not enough to have an idea of how something is working. If you want to do science, you then have to test it. Basically, you have to try and break your own hypothesis. That it's a little bit more of a modern approach. This diagram, the scientific method, has been defined by Francis in the 1600s, probably in Europe. There's more to science than that. Science, the philosophy of science, is an entire field of philosophy. Philosophy basically has like two main sections. Who's taking a philosophy class? You remember the difference between metaphysics and epistemology? Because I mix them up all the time. I think epistemology is the study of knowledge and how you can know things. And so philosophy of science is a subset of that. But basically it kept going. After they first wrote out the scientific method, I keep saying, do I have that next slide? No. It didn't get uploaded, apparently. Everybody thinks of this formulation, not in this exact figure, but this idea of make a hypothesis, test a hypothesis, try and figure out whether or not your hypothesis is working. If your hypothesis is still supported, then you can say it's contributing to the body of knowledge. That's sort of the way that 1600s philosophers in Europe thought about the scientific method. The science is a little older than that. Not much older, though, it turns out. Turns out humans did not really discover science until about the 1100s. There was a Persian philosopher named Ibn Battuta, who was actually the first one who was actually known for studying optics, which is how light works. But he was the first one who actually wrote out in a book how you can test your own knowledge, how you can test your understanding and see if your understanding matches reality. But that's still only like less than 1,000 years ago. Humans have been around a lot longer than that. We just only discovered science. Science is itself a technology. It was a scientific advance that was discovered in about the 1100s. And the difference between science and just guessing is that testing, designing your hypothesis so that you can test it. In modern scientific philosophy, we call that falsifiability. There's a philosopher named Karl Popper who came up with the idea that if you verify anything in science, you try and break it. And if you can't break it, you still don't know it's true, but you can just say it's our best guess. You don't verify anything, which sounds exhausting. And it is kind of exhausting. Science is hard because it's really hard to think, well, I don't really know if this is true or not. It's just the best guess every single time you think about anything. But that's how science works. So how does that actually apply to chemistry? How are we going to use this? Well, for starters, take nothing else away from today's lecture, introduction. We still haven't talked about what a scientific theory is. We talked about a hypothesis. What's a scientific theory versus a scientific law? Scientific, I can spell. What's the difference? But we don't prove anything in science, right? So it turns out scientific theories, this is one of the biggest disconnects between science language and everyday use language. A scientific theory can be just as well supported or even more well supported by evidence than a scientific law. The only difference between these two is a scientific scientific law tells you what will happen, and a scientific theory tells you why it happens. So that's why you can have the law of natural selection. Law of natural selection, see if I can get the formulation right, I'm not a biologist. The law of natural selection is that the most fit organism will tend to dominate a population, something along those lines. And that is a law. That's a scientific law, happens across the board, no matter what. The why is the theory of evolution. The theory of evolution is not less supported than natural selection. Theory of evolution is the mechanism through which the law happens. And so we also have a theory of gravity and the law of gravity. Newton's laws of gravitation just tell you how things fall. It doesn't say anything about why. The theory of gravitation is explaining how that happens by saying, well, anytime two things have mass, that mass is attracted to each other, to other mass. That's the theory of gravity. The law just says it falls at this rate. If you throw something with this much force, it will land this far away. That says nothing about the why, right? So scientific laws and scientific theories serve very different purposes, but they're both can be equally supported by the evidence. But what most people think of when they think of something that's not as well supported, they're really thinking about a hypothesis. I can have a guess about, I don't know, how well my daughter's basketball team is going to perform tonight. That's a hypothesis. I'm guessing about that. I have a theory if I was using common words, right? But I don't want to do that in this class because I don't have a scientific theory about how the basketball team is going to do. I have a hypothesis, and the test will be when I show up to our game. And we'll see what actually happens. Right? All right. And it wouldn't be a good introduction to a science class if it didn't have an Albert Einstein quote. Science isn't perfect, but it's the best thing we have, and it gets better all the time. I thought we would have been past this by now, but apparently, let's see, what is this title? The Secretary of Health, I don't know, RFK, basically made an argument in recent weeks, saying we shouldn't trust science because science changes all the time. That's an argument has been made for decades and decades, but it's still relevant. It's not a good argument because science changes because we make hypotheses and we test them. And when our results don't match with our hypothesis, we fix our hypothesis. We fix our theories, we fix the laws. Newton's laws of gravitation are not perfect. When Einstein came along and discovered relativity, we had to fix Newton's laws of gravity. Basically, we added a few decimal points by adding the correction for relativity. That doesn't mean that science is flawed. That means science is working. Okay, so little tirade there. Let's talk about chemistry more now. I used the word matter already, talking about gravity. Said matter is attracted to other matter, and that's what gravity is. Chemistry gets defined oftentimes in terms of matter. Because basically, well, what is matter? Things that have attraction to other things that have matter. That's kind of circular, right? Anybody have a definition for what matter is? Anything with mass is one definition. If you talk to the theoretical physicists, they might get into a disagreement about what one means the other, whether you can have mass without having volume, or if you can occupy volume without having mass. But I'm not a theoretical physicist, and this is not a theoretical physics class. So we're gonna say that basically anything that has mass will also occupy space. If it has mass, it has to take up space as well. You can't have mass that's infinitely small. Again, go talk to somebody in the physics department if you want to discuss whether or not that's true. It's true enough for this class. So that's still really, I think, because the word matter actually comes from the word mass. Actually, I think that's backwards. The word mass comes from, there's just the same root as the word matter. So we're still kind of going in a circular way, but basically, this is everything. Everything has mass and occupies space. Everything that you can see, that you can measure, that you can observe. At least as far as I can tell. Is there something that is real that does not have mass or occupy space? Light. Turns out light does have an effective mass. We can measure it. When light bounces off of it, it changes the momentum of the object that it hit. So it must have some effective mass. To stop, it would have zero mass. But light doesn't behave that way. Now we're getting into quantum and we're ahead of ourselves. We'll get there. Light is close. And light is also what's known as a fundamental particle, in that it's basically a way to move energy from one place to another. It's a means of transportation for energy. But it does have some effective mass to it. You could start getting really philosophical, deep, say, well, consciousness, ideas don't have mass or occupy space. But now we're getting into more of the philosophy side. You really could make the argument that an idea is really just an arrangement of atoms in your brain that happen to share a same configuration, and that consciousness is just the result of a bunch of nerve cells that reach a certain point. So even those kind of have some roots, and that would be a good question to ask Caroline, our A&P instructor. Maybe you have Caroline. Her specialty is in neuroscience, and so questions about consciousness and perception and things like that. From the science side, go see what she says, because she probably has better answers than I do. Turns out neuroscience is really, really complicated. Not like it's brain surgery, right? So basically, chemistry is a study of everything we can see. We're not going to study ideas so much, or consciousness, really. Might touch on it in some of those random quiz questions, but what we'll actually study in this class is stuff that we can touch and see. Basically, it means that what we're going to learn about in this class is everything. Everything has roots that come back to chemistry. And we can kind of see the way that the different scientific disciplines interact with each other too, in looking at modern medicine is a good example. Basically, what we consider modern Western medicine is basically where biology and chemistry overlap. Our knowledge of biology is based on how chemicals interact within living systems. Most modern medicine is a way of tweaking those chemical concentrations somehow in a way that produces a desired result or treats a symptom. So basically, if you want to do medicine in any capacity, you've got to understand both the biology and the chemistry. And it turns out you can do something similar with pretty much every scientific field. Chemistry is what's known as the central science, because every other science touches chemistry somehow. So here's a blown up version. Chemistry sits right in the middle of a ton of these other things. Medicine's up here with biochemistry, toxicology, biology, food science. You could actually put that one even closer to chemistry, and environmental science. food science and agriculture. Turns out modern agriculture, you have to understand chemistry and biology in order to do modern agriculture. It's a really fascinating field. Looking at soil, it turns out soil is really, really interesting from a physical, chemical, and biological point of view. You need all three of those characteristics to be able to grow something in it. And if you don't understand that, you wind up with a situation like the 1930s in Oklahoma, the Dust Bowl. Basically, they were taking care of the physical aspect, but ignoring the chemical and biological aspect of the soil. And it created a giant catastrophe where nothing would grow for a long time. It could be argued that chemistry is just applied physics, but it's applied really well, and the physicists don't really do a very good job of actually doing anything in the real world for the most part. So chemistry is basically like physics made useful. Yeah, you can tell Bruce I said that. Bruce, the physics and math instructor, is one of my best friends. We have an ongoing debate about whether chemistry or physics is more important, because chemistry really is just physics. But anyway, math, you could say, is the furthest removed from chemistry. We use math. We don't actually contribute other than supercomputers. You can't have a supercomputer without chemistry. And supercomputers are really important in modern math. Anybody interested in science that aren't on this chart? Is astronomy up there? Usually somebody's earth sciences. You keep going out this way, you get astronomy, maybe astrophysics. Turns out we need chemistry to understand how planets form too. Maybe not how they form, but what they're made of, how they interact, things like that. Any of these are fair game for random questions. You answer the random questions at the weekend. We're gonna end here in a couple minutes. If you want to ask random questions, tell me what you're interested in, what field you're majoring in, what you're studying, what you like thinking about. Anything on here is fair game. So here's the plan. Normally, I think we go until 12:25 normally. We'll end a little bit early today. We will not have lab this week because we didn't have lab Monday. It's Wednesday. It just feels weird because it's middle of the week, but we're starting first day classes, right? So on weeks where we don't have Monday classes, we won't have Wednesday labs either, in order to keep everybody on the same schedule. So we won't be meeting labs. If you want a paper copy of the math review, we have some printed out down in lab. And you can come find the chemistry lab. Anybody who wants to learn where the chemistry lab is, see back at the offices, come with me when we're done here. We'll just walk on down to the labs over there in the offices. So your assignments this weekend, math review, and take that quiz. This first quiz is showing you how to take a quiz on Canvas. It's what are you into? Ask me a question. You get 10 points for it just for hitting submit. As long as you don't. Okay. All right. Then anybody who wants a paper copy or wants to find where lab is, come with me. Everybody else, I'll see you on Monday. So,